Good morning, good afternoon, good evening, and welcome to day one of the Fairfax County Economic Development Authority's Air and Space Innovation Series. My name is Juhi Nathani, and on behalf of the FCEDA, it is my distinct privilege to lead you through today's proceedings. Our three-part series promises to be an exciting, engaging, and informative affair where you will hear about the latest and greatest in emerging technologies in aerospace, as well as get more familiar with the significant players that operate in this space in Fairfax County, Northern Virginia, and beyond. Before we begin, a few housekeeping notes about Whova, the event platform that we are using. All pertinent information about the series is available on this dedicated event site. The main menu on the left of the page if you're on the browser, or at the bottom of your phone screen if you're on the app, is your guide to navigating the show. If you face any difficulties with audio or live stream, please refresh your browser or app, and that should take care of it. We really hope you've been networking with your peers leading up to today, but we're pleased to offer live networking on each day of the series on the Hoover site. Today, you can speak with many of our presenters at 10:35 a.m. US Eastern Time by visiting their company networking rooms through the meetups and virtual meets under Community menu item. At any time, you can also ask the organizers any questions that you may have, again through the community link, and ask organizers anything. You can also submit questions to the specific sessions on the agenda item that you're interested in. Just click to the session, click on the Q&A box, and type your question there. Okay, so back to day one. Today's program brings you breakthroughs in aviation innovation from passenger travel to flight monitoring to unmanned air vehicles and systems. Before we go into all of that, here to offer welcome remarks, we have President and CEO of Fairfax County Economic Development Authority, Mr. Victor Hoskins.
Thank you, Juhi, for the opportunity to offer opening remarks. As Juhi said, I am President and CEO of Fairfax County Economic Development Authority. We promote Fairfax County as one of the world's best business locations, and we are here today to spotlight industry sectors that put Fairfax County and the surrounding Northern Virginia area on the map as a business destination. My office has been very busy working on COVID-19 related issues and helping businesses obtain financial assistance and technical assistance so they could bridge the pandemic. I'm very proud of the work that we've done over the last 10 months. For example, we have marketed a Fairfax County program that allotted more than $52 million in grants to 4,800 businesses, saving jobs and households. We also want to highlight those industry sectors that are very strong here and that certainly includes aviation, aerospace, and defense. I'm delighted that the FCEDA business investment teams led by Juhi Natahi, Asher Coates of our International Business Investment Division have put together a program that focuses on one of my favorite topics, innovation. In aviation, aerospace, and defense, Fairfax County and Northern Virginia are a hotbed for innovation. One of my goals is to make Fairfax County in Northern Virginia the innovation center of the Western Hemisphere. The program today, February 3rd and February 10th, gives you a great idea how strong these sectors are, and we are thrilled to have the presenters and panelists who are going to outline the amazing developments in their industry. Fairfax County is home to some of the biggest names in defense and aerospace. Fairfax County is a leader in supplying technology, ideas, and hardware to keep our country safe. Year after year, more federal procurement dollars are awarded to companies in Fairfax County than any other locality in the nation, including billions of dollars in defense-related contracts. 8 Fortune 500 defense and aerospace companies have operations in Fairfax County. 2 of them, Northrop Grumman and General Dynamics, are based in Fairfax. 8 of the 10 global defense companies have operations in Fairfax County. You will know just how strong our international connection is, as we go through this program. We have presenters from Airbus in Europe, Israel Aerospace Industries based in Tel Aviv, and OneWeb based in London. This industry is part of the tech ecosystem that includes more than 8,800 companies, a workforce that is almost one quarter focused on tech, a talent pipeline that includes George Mason University and universities throughout the DMV, and thousands of former military who have settled here after retirement or separation from work in this sector. On the demand side, we have federal agencies, government contractors, and Fortune 500 companies. On the supply side, we have dozens of US and international companies, many small and minority-owned businesses, trade associations, and industry groups, and universities throughout the region. Congratulations to our business investment team, including our reps from London, Tel Aviv, Bangalore, Mumbai, Berlin, Seoul, and Los Angeles, for organizing this event and getting the word out. Congratulations to you and our special events and communications team for producing the event and getting the word out about it. And thank all of our partners in this, in particular, the American Institute of Aeronautics and Astronautics, Aviation Week, and Jane's International Defense. Thank you and have a great program today.
Thank you, Victor. That is absolutely awesome. It is now my pleasure to kick off today's proceedings with an opening keynote address by Ms. Amanda Simpson, Vice President for Research and Technology at Airbus Americas. In this role since 2018, Amanda brings extensive experience in the areas of energy procurement, research and development, acquisition, logistics, and technology as it relates to aerospace. Amanda was appointed by President Obama to serve in his administration and held various roles there until she ended her public service as Deputy Secretary of Defense for Operational Energy in 2017. Ms. Simpson holds both an airline transport pilot certificate and a certified flight instructor license. She has logged nearly 3,000 hours of flight in more than 60 different aircraft. Please welcome Ms. Amanda Simpson.
Well, good morning, and thank you, Julie, and thank you, Victor, for having me this morning. Normally, I would be in my office as Vice President for Research and Technology for Airbus Americas. I oversee all the research, technology, and innovation activities across all the Airbus units, both internal and external, across all the Americas. And we are headquartered in Herndon, Virginia, right there at the kind of the corner of Fairfax County. I coordinate everything for our commercial aircraft, helicopters, defense, and space operations. And so as though we are a European-based company, Airbus Americas is a US company. We have over 7,000 employees in North America across 25 different sites. And we support over 300,000 jobs in North America as 40% of all of our aircraft come from North America, thus making us the largest aerospace exporter in the United States, spending over $50 billion in the last 3 years. But let's go ahead and start my slides. Today, I'm really going to focus on what we're dealing with today, particularly due to the pandemic. But then also, what are we looking at for the future? Because we do indeed see the innovation as critical to what the future of aerospace is going to look like. So next slide. So I'll talk about, well, one of the biggest issues everyone's concerned about, which is getting on an airplane, am I going to catch COVID? So I'll talk about what we have seen and what we have devised with regards to the cabin air quality. And then we'll talk about one of the very, very important things to Airbus, and we think to everyone, which is how do we look at the environmental impact of aviation and what can be done about that to reduce our impact in the future? I'll talk about a few solutions that we are investigating and how they will change the way we all fly. And of course, this is all about flying cars, drones, and air taxis. So I'll talk about some of the things that we've been doing, but also talk about them in general and what does that mean for all of airspace. Next slide. So I'm going to talk about the clean air on board. We call this our Keep Trust in Air Travel initiative. We are partnered with all of the aviation and commercial aircraft manufacturers. We are partnered with our airline customers. We are partnered with suppliers. We are working to make sure that our cabins are clean and that passengers feel comfortable traveling safely. So let's go ahead and I'll just jump to the next slide. And this is a little bit about how the air flows in an aircraft. You know, contrary to the initial concept that when you get on the plane and they close the door, you're sealed in a tube and that's all the air you've got for your whole flight. That's actually about as far from the experience as what happens. What really happens is that the engines on the airplane are always breathing very, very clean air. And part of the air that is going into the engines goes into air conditioning systems under the floor of the cabin. And what they're doing is they remove ozone, they clean out and cool that air because it's been compressed. And then it is provided into the cabin as clean, fresh air. Now, that's about half of the air that goes into the cabin. The other half of the air that's going into the cabin is recirculated from, of course, the air that's already in the cabin. That air goes through a series of what are known as HEPA filters. Those HEPA filters are quite amazing. They were actually developed, to give you a little history, they were developed back during the Manhattan Project as a way to protect scientists who were working on radioactive materials from breathing the radioactive dust and particles that was being developed as part of working on those very dangerous materials. HEPA filters are routinely used in hospitals to clean the air in operating rooms. They remove more than 99.9% of particles, viruses, and bacteria. And so they are very, very clean. And there are usually, depending upon the aircraft, 2 or 3 very large HEPA filters that are used to clean the air. So the aircraft, the air is recirculated. About half of it gets recirculated. The other half gets dumped overboard. And then it is always refreshed with air from the outside. And what that means is you will be replacing, or we are replacing all of the air in the cabin on about a 2 to 3 minute process. So always getting very fresh air, always getting very clean, very safe air. Next slide. So this kind of shows what's going on with the air in the cabin. The air that comes into the cabin enters along the roof line. It is being blown in above the luggage bins, along the wall, and of course coming down through those little adjustable gaspers, as we call them, above your head. So all the air flows from the top down to the bottom. It is then evacuated from the cabin along the joint at the floor where it meets the walls. Air does not flow from front to back or back to front. It only flows from top to bottom, so that there is very, very little airflow between rows or between seats. That airflow is about 1 meter per second, so it's a little bit of a breeze, not so much that you feel it unless you turn on the gasper and it's absolutely blowing on you, but it is indeed always providing very fresh, clean air for each and every person on board the aircraft. So some of the things that we've done, I look at it as a 3-legged stool. evaluating how clean and fresh the air is and how safe it is to travel even today. So Airbus, Boeing, Embraer, we've all done what we call computational fluid dynamics, evaluating the flow of air through the cabin through advanced computers. These have been validated by an independent study by Harvard University that through computational showed that it is very safe. And even if a person is sick next to you, you have a very, very, very low probability of catching what they have. Now, that's one leg of the stool. The next leg of the stool has been that there have been actual experiments, some done by the airlines. There was one very notable done by the US Department of Defense, where they actually put viruses on dummies in an aircraft, had them expelled, and then took measurements of how far those viruses traveled and whether they would have infected other people in the cabin. And those studies showed, again, a very, very low probability of transmission in the cabin. And of course, the third leg of the stool is the actual numbers, the actual results. If you look at the billions of people who have traveled during the pandemic versus the number, very, very small number of people who have actually been infected or presumed to be infected by traveling on an aircraft, the probability is of catching COVID on board the aircraft is extremely, extremely small. So, you know, aircraft were designed this way right from the beginning. You know, we learned from previous outbreaks of SARS and MERS and others, and we are prepared and have been prepared for what is going on in the pandemic. We're also working with the airlines on various ways to clean the surfaces of the cabin, and we have been responsible for ensuring that various cleaning techniques and technologies don't damage the aircraft, because quite frankly, you wouldn't want something that was used in the aircraft that would damage, say, the instruments in the cockpit or reduce the life cycle of some of the components. So those are the things we're looking at. We're also evaluating new materials for the future, new systems for, say, touchless lavatories to make everything cleaner, to make everyone safer on board an aircraft. But right now, it is indeed safe to travel in an airliner. So moving on, next chart. We're going to talk about one of the longer term issues, which is the environmental impact of aviation. And what you see here on this chart is what is the CO2 emissions from aviation. And you can see the dip in 2020, and then we expect it to once again continue to grow as air travel grows, which is historically at about a little over 3% per year. The problem is we've got to stop the amount of emissions. And the agreement and the industry goal is to get that down to half of the 2015 emissions by 2050. And we're looking at a variety of different ways, and you can see those by the colors. One is, and this is already happening, airlines are offsetting their carbon emissions by various economic means. One of the things that is being touted very much in the future is sustainable aviation fuel, which would utilize carbon dioxide already in the atmosphere and recycle that into aviation fuel, thus reducing the amount of new emissions that are going into the atmosphere. That thin orange stripe, that's in operations and infrastructure. That's about how we fly. It's reducing the amount of time that aircraft are actually on their route or at altitudes where they are emitting more carbon dioxide than they do today. So it's becoming more efficient. It's reducing, delaying start time of aircraft so that they don't have to hold when they get to their destinations. There's lots of infrastructure and operational considerations that are going in. And then the blue is what do we have to do with regards to coming up with new technologies to close that gap in the future. And you can see that that blue starts in about 2035, because technologies that are being looked at today won't actually be put into operation at the earliest till the mid-30s. So I'm going to talk about what some of those options are. So let's go to the next chart. So some of the technologies we're looking at, you know, we call it the DISCO, the disruptive cockpit, which is adding automation and capabilities to the aircraft, because we believe that there will be a need for single pilot operations. And what does that mean? It means, like I said, more automation, more autonomy, bringing some of those capabilities that I talked about in operations actually into the cockpit so that the aircraft operates more efficiency and thus is reducing the amount of carbon dioxide emissions. Wayfinder is a project that is looking at autonomy. This was a spinoff of one of our projects I'll talk about a little bit later, Vahana, and they built a certified and scalable autonomy system for self-piloted aircraft. And they are actually using that as part of the next project, the autonomous taxi takeoff and landing tests that were done last year, which uses computer vision to navigate and detect obstacles. And we actually have done automated taxi, completely autonomous, hands-off, landings and even takeoffs of our largest A350 twin aisle airliner. And if you ever get to see the videos, you can watch the pilots sitting there with their hands off the controls as the aircraft performs these maneuvers, takeoffs, landings, and even taxi. Next chart. Well, we think there's really going to be some real groundbreaking technology needed. So late last year, we announced our Zero-E concept aircraft, which are completely zero emission. And they are going to be powered by hydrogen. Hydrogen, of course, when you burn it, all it emits is water vapor. So we rolled out 3 concepts, and you can see those there. I'm going to bring them up in the next chart in a moment. But the idea here is that if you change the source of the fuel, rather than burning hydrocarbons, you're burning clean fuel. So next chart, these are the 3 aircraft, turboprop, turbofan, and something a little bit more modern or advanced, which is the blended wing body. But, you know, so these are 100 to 200 passengers, 1,000 to 2,000 mile range. Another concept that we brought up recently, next chart, is what we call the pod, which are, these pods are fully self-contained systems. They have fuel tanks, they have the engines, the advanced propellers that would reduce and make maintenance simpler, as well as an introduction to bringing hydrogen to aviation. Right, next chart. I'm going to just briefly talk about our Perlin 2. Perlin 2 was a manned glider that a few years ago we used to set an altitude record of over 76,000 feet. And we're going to use this glider to do some measurements on what are the effects of burning hydrogen at altitude and what are the environmental impacts. So this was an amazing unpowered aircraft that made it up to, like I said, over 76,000 feet. Next chart. Zephyr is an unmanned solar powered aircraft, also for Earth observation. We set a record that this aircraft was able to stay airborne for 25 days, 23 hours and 57 minutes. We landed a little early. We missed the 26 day record. But, oh, well, what we set was a record. But these are things that we're doing to help monitor what are the environmental impacts of aviation. Next chart. And of course, we have numerous. We are one of the world's largest builders of environmental monitoring satellites. I've listed several of the constellations that are out there that are either optical, infrared, or radar that are monitoring our planet to understand what is happening to the environment. Next chart. So talking about unmanned flying cars, Vahana was a project that was done up in Oregon. It was a single seat, completely autonomous vehicle. It conducted over 100 flights. It was able to demonstrate over 50-mile range, all on electric power. Videos are available. They're very interesting. Again, completely autonomous, vertical takeoff and landing. Get in, push a button, and off it goes to your destination. Next chart. We're looking at City Airbus. This is, I jokingly call it the world's largest quadcopter, but this one holds 4 people, and it's undergoing testing out in Germany. It is optionally piloted, and it is getting ready to be go through certification trials. So other things that we're looking at with regards to flying taxis. Next chart. This is a project that we've been doing in Singapore. This is bringing supplies out to ships in the harbor. So again, a completely automated system that carries packages back and forth and brings critical supplies out to the ships. Next chart. I'm going to talk a little bit about Altascope, and I think you're going to hear from some others earlier, but this is looking at the impact of having hundreds, if not thousands of vehicles now in an urban environment. How do you coordinate? How do you make sure not only that they all reach their destination safely, but integrate weather, routing, collision avoidance, micro weather, what's weather like down between buildings, ensuring that an aircraft's going to have a place to land before it even takes off. How do you handle emergencies, et cetera, and integrating with helicopters, package delivery vehicles, and of course, other aircraft that are operating in these spaces. Next chart. So I've probably gone over my time, but I hope you find this very interesting. I will be around later to answer some questions. And with that, I will turn it back to Julie.
Thank you, Amanda. That was a fantastic presentation, and it's really heartening to know that despite all the challenges, we do have a lot to look forward to in the world of aviation technology. Speaking of which, our next segment is a demonstration of cutting-edge innovation in aviation. The presenters on your screen will walk you through technologies they have developed to enhance applications in various aspects of flight, both manned and unmanned. Allow me to introduce your moderator for this technology showcase, Executive Editor for Technology at Aviation Week, Mr. Graham Warwick. Born and raised in Scotland, Graham has a degree in aeronautical engineering and was an engineer at Hawker Siddeley Aviation, if you remember the Harrier, before he became an aviation reporter. Please welcome Graham Warwick.
Thank you, Juhi, and welcome everyone to this aviation technology showcase. Despite the damage wrought by the pandemic, this is a remarkable time for innovation in aviation technology, from medical drones to urban air taxis to many of the things that Amanda talked about. Today, we are featuring 4 companies that are at the forefront of ushering in some of those technologies that are going to enable this new age of aviation. We're going to hear from drone operating system provider ANRA Technologies and its CEO Amit Ganju, global air traffic surveillance provider Aerion and its CEO Don Thoma, unmanned cargo aircraft developer Elroy Air and its CEO Dave Merrill, and working with the industry here in Virginia to advance the use of drones, the Virginia Tech Mid-Atlantic Partnership and its director Mark Blanks. If you have questions for our guests today, don't forget you can use the Hoover app, and you also will have an opportunity to network with them later on that same app. So now we're going to get on with our showcase. So if you could please get our first video up and going for ANRA Technologies. ANRA really does a broad range of enabling technologies for drones, and we're going to see their vision of the future, and then we're going to talk to their CEO. So off we go. Thank you. Now we're joined by CEO Amit Ganju. Hello, Amit. How are you today?
Hey, Graham. Good morning. Thank you.
Good morning. So that is a great vision of the future. How far away do you think that is? And what progress are we making in laying the foundations for that future?
So I think you have to look at it in bite-sized chunks, Graham, because the autonomy and the whole unmanned space is pretty huge, ranging from small UAS moving all the way to flying taxis, flying cars, or Jetsons becoming a reality. And depending on which part of the world, because we are in aviation is a regulated industry. So the regulatory frameworks are evolving at different paces in different parts of the world. So it's not, so what's happening in North America is not necessarily the same thing that's happening in Europe or in Asia. So the way I like to talk about is like innovation, experimentation, and operationalization. Those are the three phases you have to go through. So depending on which part of the world you go to, different industries, different verticals are at different phases. So in some cases, like if you take US as an example, so we started this early on with small UAS, innovation, experimentation, and now we're transitioning more towards operationalization with the rulemaking coming into place. And then if you start going to other parts of the world, they may still be in innovation and experimentation, not quite at the operational phase. From a small US low altitude airspace point of view. Now, as you start moving into non-segregated airspace, mixed use airspace, as you start transitioning to the more bigger aircraft, unmanned aircraft, like UAM aircraft, like Dave's Elroy Air, like doing mid-mile logistics, or UAM, unmanned cargo and unmanned people. That is still in the crawl phase. And so there's a lot more work that needs to happen, but we have come a long way over the last 4 or 5 years, but there's a lot longer to go. I don't know if that answers your question.
No. It's so I mean, you're a UTM provider today, and you're doing that not just in the US but in other parts of the world. So what sort of things are you already enabling? You know, what breakthroughs or new services that drones can provide are you already allowing to happen?
So UTM is, unfortunately, UTM is one of the most abused terms out there because you talk to people and people say, yeah, we have UTM. UTM is the glue that holds everything together. It's a framework to help enable the safety of the airspace, the national airspace. And there are core functions like, hey, strategic coordination. How do I ensure flight going from point A to B is deconflicted from a flight going from point C to D, and they're intersecting in space and time. So it's not just that strategic deconfliction, then maintaining that separation tactically, and then ingesting constraints and other aspects. So in terms of what's happening out there, like if you look in, there are some deployments like where people are trying to leapfrog. They're trying to do the nationwide operational airspace management right from ground zero, like in, for example, in some countries in Asia where we are involved, they're saying, okay, we're coming from behind, but we are going to lay this policy and just do it, mandate it for the whole country. Whereas if you look in what's happening in US over the past few years, you had incremental, a baby step that was taken towards that with the LANS, which is a low altitude airspace authorization and notification in control zones only in and around airports. And in other parts, like if you go to Europe and Switzerland, for example, they just rolled out a nationwide remote identification capability, because UTM is just airspace management, remote identification, and more. So it's network-based remote identification that they just did a friendly launch. We deployed in December, and it's going to go live in March timeframe. So there are bits and pieces, and then there are, like in US, you have these waivers and exemptions where you can set up these corridors where I can do these BV laws, because visual line of sight operations is kind of norm now with Part 107 kind of things in US. But as you move towards, the real applications happen when you move beyond visual line of sight. So so the UTM, like I said, the airspace management, because airspace management helps build the safety case for beyond visual line of sight operations. So if I'm doing a linear inspection, or whether it's oil or gas pipeline or power line, how do I build that? So we see a lot of those, I shouldn't call it one-offs, specific approvals happening for those. They're not for masses, but they are very specific to a particular vertical, particular industry.
How important is it for governments and regulatory agencies to really sort of lean forward and support this? I mean, what do you want to see happen? Do you want this sort of more engagement, more support to drive this forward?
Yes, absolutely. Because in the regulated, that's one of when people say, what's the biggest challenge you're facing? It's the regulatory framework, because technology already always moves at a faster pace than the regulation. But what we are seeing is doing stuff like IPPs in US and similar pilots and trials. That is very useful when it comes to not just doing a paper drill and saying conceptually or working on ConOps, taking the ConOps and actually exercising them in real world environments, and then transitioning from there, seeing it's not just the technical acceptance, it's the regulatory acceptance and the local and public acceptance as well. All of them kind of play together to introduce these services. And then the challenges are a little bit different as you transition towards urban air mobility as well.
Yes, but I think we are beginning to lay the foundations. And I think the important thing that you've talked about is this operate, then regulate. We need data to have regulations. And I think the approach that you're talking about is very much about generating data that we can then make informed decisions about regulation. So Amit, thank you very much for introducing us or telling us about ANRA. We will now move to our second company of the day, which is Aireon. And they are a provider of global air traffic surveillance. So could we play their video, please?
In more than 70% of the world's airspace, air traffic controls still rely on visual position reports, flight plans, and estimated locations to track aircraft. That is changing. Aireon has created the first 100% global air traffic surveillance system, delivering real-time aircraft positions in every flight information region in the world through Automatic Dependent Surveillance Broadcast, or ADS-B. International mandates already require the vast majority of aircraft to transmit their position using ADS-B. The Aireon system turns these signals into aircraft on the screens of air traffic controllers across the globe. The Aireon system is a cutting-edge constellation of 66 low Earth orbit satellites. With Aireon, air traffic controllers receive an independent layer of surveillance, covering 100% of their sector in a data format they're familiar with, but with improved accuracy and speed compared to traditional ground-based systems. Finally, Aireon's space-based service provides an alternative to the multiple layers of current ground-based infrastructure, reducing maintenance costs, risk, and complexity. The future of air traffic surveillance is here. To learn more about these benefits and what space-based ADS-B can do for you, visit Aireon.com.
Thank you. And now we're joined by Aireon CEO, Don Thoma. Hi, Don.
Hi, Graham. Thanks
Good.
for having me.
Thank you. It's a great system. Where are you actually in deployment? Are you fully deployed, fully operational, or are you still in the process of rolling things out?
Yeah, so we launched on board the Iridium constellation. As you may remember, Graham, they completed launching back in 2019. So we went live with our service in March of 2019. So we've been operational for almost 2 years at this point.
And what sort of outcomes are you seeing from those the people who've signed up to use your service? What sort of things are they being able to do they couldn't do before?
Yeah, no, it's a good question, Graham. As you know, we have roughly 19 countries around the world, or excuse me, 19 air traffic control organizations representing 39 countries around the world who are using this service for their air traffic control capability. So typically what we do is provide, for example, the FAA or Canada, all of their airspace data on all the aircraft movements going on in their airspace. They in turn use that with their air traffic, by their air traffic controllers, to do a number of things. And we've seen some really interesting results of the first 2 years of service. I mean, the first benefit that we've seen is the improvement to safety. I mean, you can imagine, as the video said, when you fly over the oceans, air traffic control isn't watching you in real time. They're getting updates every 10 minutes as to where your location is. So you can imagine they keep those aircraft pretty far apart to ensure safe operations in that airspace. And what we've seen is substantial improvements in safety. For example, a typical problem in an oceanic area is the pilot will set the altitude of the aircraft to an improper altitude, one not cleared with air traffic control. It, on average, before using space-based ADS-B, was taking 50 minutes to get the aircraft back at the proper altitude. With it, space-based ADS-B, they're now seeing 5 minutes on average. So huge improvements to the safety metrics in these remote areas. But more importantly, from an airline perspective, the airlines are getting the exact profiles they're looking for, right? They're getting to fly the optimal jet stream track. They're getting the right altitudes for the performance of the aircraft. They're being able to fly at the optimum speed, some substantial improvements in fuel savings to the airlines, but equally important, it's reducing the amount of greenhouse gas because they're not burning as much fuel.
So you did an agreement with the FAA in November last year, and the FAA said in its announcement that it was going to planning to use Aireon data to explore innovative uses. Do you have any idea what the FAA, how important is that to you to have that agreement with the FAA? And also, what sort of things do you think that you can start to explore now that they are going to look at your data, use your data?
Well, Graham, the FAA has been a great partner for Aireon, and they've been involved in the program really since the very beginning, since the 2012 time frame when we started the project. So they've been involved with us on a cooperative agreement. They're obviously the leaders in deploying this ground foundational technology, automatic dependent surveillance broadcast. So they've had a lot to offer to us as well as the global aviation community. So this agreement's really important because it's a culmination of multiple years of work. I mean, it's a several phased agreement. As you know, the FAA has a unique role in the aviation community. Here in the U.S., they have both a safety regulator role to ensure the safety of air travel, not just in the U.S., but of aviation and U.S. travelers globally. In addition, they operate a huge amount of airspace, 20% of the world's oceanic airspace, in addition to the large terrestrial airspace. So, very important expertise base and foundational capability the FAA has to exploit new technologies and deploy them. So part of this agreement is, in fact, to provide and use this capability in these large oceanic areas where the FAA operates a substantial amount of air traffic. And there's a phased approach they've identified to deploy this, upgrade the other tools that the air traffic controllers use to ensure they can deliver those safety benefits, those efficiency benefits that we've talked about. But the other side, which I think is equally exciting, is that we've been working very closely with the FAA on using this global data set to develop other applications that support their safety mission. So for example, we've been working with them on a global monitoring system for monitoring the 737 MAX return to flight, an early warning system. They've deployed this capability across their centers for a search and rescue capability. We've had multiple areas where the Ariane data has been used to rescue pilots who've been down in the ocean. They're doing a whole series of safety analysis on various sets of airspace where they haven't had the data that's been available for that. And even things like commercial space. As you know, the tempo of commercial space activity here in the U.S. has really increased. So they're using this data to understand what happens to the airspace when they close it for a space launch, and how can they improve their operations to minimize the impact on global aviation during a space launch.
Oh, that's interesting. So you mentioned the explosion in space activity. You're the first to do this. Do you expect you'll eventually face competition, and what do you do to stay ahead? I mean, what are you looking at to keep yourselves ahead of the other guys?
Well, as Amit mentioned, the aviation community is extremely safety oriented, and which means they take very careful steps in validating the data. So, in our case, we've worked very, very closely over the past 8 years in developing a system, testing it, validating it, certifying it to support safety of life applications like air traffic control. So, in this case, there's a lot of work you need to do to support this fidelity of data. We're also lucky that we've been able to partner with Iridium. We spun out of Iridium originally. We're a hosted payload, if you will, on their system. That is a system that's very, very unique. It provides global coverage and access to this information on aircraft in real time. So it would take a lot of effort to duplicate this capability. But even more important for us, it's the partnerships that we're developing with our customers, within the industry, and the capabilities we're investing in. So, for example, we've been investing heavily in taking this data set and putting it in a cloud-based format with big data analytics tools on it that now allows other organizations like the FAA, like safety organizations, airport operators, airlines to use this data to support their operations as well. So I think we've got a good head start. Obviously, there's always competition coming. We welcome that, of course, but I think we're in a good shape just based on the capability we've developed, the head start we have, and the innovation that will continue to perform.
Thank you, Don. I think this is a fantastic system. It's a great combination of safety and efficiency, which I think really is the hallmark of the great innovations of aviation, where you got those two things that come together. So thank you very much,
Thank
Don.
you, Graham.
And we will now move on to our third presentation of the day, and that is Elroy Air, which is a unmanned cargo aircraft developer. Could you roll the video, please?
As the world becomes more connected, logistics has to adapt to keep up with demand. Today, more than 1 billion people live in communities outside the reach of reliable roadways. In other places, traffic congestion is continuing to grow at an alarming rate. At Elroy Air, we are working to solve these problems with autonomous flying cargo systems that don't depend on ground infrastructure. Introducing the Chaparral, a hybrid electric aircraft capable of carrying up to 300 pounds of cargo over 300 miles without the need for airports. The Chaparral's vertical takeoff and landing capabilities mean that every loading dock, every parking lot, and every flat surface is a potential delivery location. Our cargo containers are separate from the aircraft. Once a cargo container is packed, it is set outside for pickup. The Chaparral taxis over the container, picks up the cargo, then takes off vertically. The vehicle transitions to wing-based flight and recharges its battery en route to its destination. When the Chaparral lands at the destination, the system will deliver the container and pick up another for the return flight. We believe that extending the reach of express logistics can improve the quality of life around the world. This is a rare moment where technology can leapfrog today's infrastructure challenges. The Chaparral can connect the dots between people, places, and goods in ways that were not possible before, delivering rapidly to warehouses, hospitals, and communities in need around the world.
thank you. And now we're joined by Elroy co-founder and CEO, Dave Merrill. Hi, Dave. How are you?
Hi, Graham. Doing well. Thanks for having me today.
Good. So the video talked about a couple of key things there. It talked about hybrid electric and it talked about the automated pod system. So could you just sort of say, what are the key features and why does it set what you're doing apart from, it is a very active market, this regional cargo at the moment. Your approach, what sets it apart and why are those technologies important to you?
Sure. So our mission at Elroy Air is to enable same-day shipping to every person on the planet. And to answer your specific question, every aircraft is designed with a particular mission in mind. And we found an enormous demand for accelerating middle mile logistics, both in the commercial express parcel community, big multinational shipping companies, as well as in defense logistics. And so the two particular things that we're doing very differently than most air taxis, for instance, are number one, the hybrid electric powertrain. And that derives right from the mission that our customers need. If you look at, the best available battery technology today, it's getting better incrementally year over year. But, you can only get 50 to 100 miles of range for a vertical takeoff and landing aircraft at this scale on all batteries, depending on how much reserve you need. So we're developing a hybrid electric powertrain that, like it said in the video, takes fuel and then recharges. It does have a battery on board, recharges that battery in flight. And that enables a 300-mile range that we're developing for. So, a lot further, and it actually meets this middle mile logistics need for commercial express, as well as a number of defense customers need. And then the other piece of it is the automated cargo handling. And this is, inspired by warehouse robotics and the way that if you look inside an Amazon warehouse, you see this coordination of people and machines to enable this really efficient flow of goods out of the warehouse. So what we've done is created modular cargo pods that can be packed up and made ready before the aircraft has even finished the mission that it's currently on. Those get staged, and then the aircraft gets assigned and it taxis around, picks up the cargo pod, and will fly it from A to B. So that kind of separation of the pod from the aircraft, it's like borrowing a page from drop freight with ground shipping logistics, where you can load up a trailer first, and then as soon as that driver and power unit is ready, they just latch to the trailer and go. So you don't make the driver wait around. In our case, it means, unlike today's traditional air cargo, you don't have the aircraft waiting around to be loaded on the at location A and then unloaded at location B, where you lose a lot of time.
All right. So where are you in development of the Chaparral? I know you've done some initial flight tests with the vehicle, but you're now moving into the more formal development certification phase, I presume.
Yeah, so let me catch you up. Just kind of quick history. We started the company in 2016, and to date, we have built a fantastic core team and technical advisory board. We've designed Chaparral based on extensive customer feedback from the defense and commercial logistics partners that we have, developed a robust software and autonomy architecture, designed, iterated, and patent protected the cargo automation systems that I mentioned that will enable contactless pickup and the drop off of cargo pods. We did fly a full-scale prototype system in 2019 at Camp Roberts, California. And that was actually a huge milestone for us, big accomplishment, as only a few teams in the world had done that kind of flight for an electric or hybrid electric VTOL aircraft at this scale. We're now validating full envelope flights in our detailed simulation environment that models all the dominant effects of the aircraft, and building an iterated version of the aircraft to enter the next flight campaign later this year. We also have more than 10 letters of intent from big commercial logistics companies and airlines that are worth an estimated 500 million in future revenues. And we have 2 contracts with the Air Force that are providing a pathway to a defense sales opportunity with the Agility Prime organization, as well as other branches of the DoD. And so with regard to the aircraft, we're updating the aircraft design now and building an iterated version. And these systems will be built by mid-year, and then we'll be starting the next flight validation campaign in the 4th quarter of this year, which will run into 2022 to full envelope flights, and we'll start a low rate initial production line in 2022 to develop systems for our customers.
Right. Before I go any further, just a gentle reminder, if you have questions, please put them in through the Hoover app. And so you mentioned customers there. So how do you see this rolling out? I mean, this is not an easy problem. You're talking about unmanned operations, in national airspace. So how do you see it rolling this out? Are you going to start in parts of the world where it's easier to do that? Do you see the military being in the first place? Or do you think that here in the US, you will see an early uptake in this idea?
It's likely the former. So as I mentioned, we have multiple contracts with the US Air Force, and they've really leaned in. There's a group called Agility Prime in the Air Force, which is really the home of electric VTOL and hybrid electric VTOL development. And it's a fantastic locus of activity. The Air Force is partnering with companies like us to provide in-kind support for flight testing, for technical advising and development, for military flight authorization. And the goal is to provide a pathway to sales so that we can become major provider of systems into the Agility Prime organization. And they're planning to build an initial operating capability, the first fleet in 2023. So that's defense is often an early adopter for new aircraft systems, as you know. And then for commercial customers, we have more demand than we'll be able to serve in the first few years, ready to go. But we do think that there's an opportunity to start the initial deployments overseas in airspaces where our customers and the civil aviation authorities have already demonstrated that they can fast track new UAS systems into the airspace for commercial operations. So you could say this is taking a page from the Zipline playbook, where that company started in Ghana and in Rwanda and built an initial operating capability, scaled it, and now is moving back to the US as they sort through the regulatory frameworks for operating here.
So just one quick finish up here. How do you roll this out in terms of the autonomy? Do you begin remote piloted and then, one pilot to one aircraft, and then you go to like one ground control or multiple? How do you sort of roll that out?
We do. So we're developing the Chaparral to be an autonomous system. There is no joystick. There's no stick to surface direct, minute to minute control or second to second control that a pilot will have. However, that said, the FAA, does rightfully have what they call a crawl, walk, run approach to integrating new systems. And so we are going to have a system that is autonomous, but has a one-to-one remote pilot in the early days. And that pilot will be monitoring the flight. They can intervene if they need to make a decision, but they're not going to be directly piloting that aircraft, with a joystick. And so what we see the trajectory looking like is after a period of one-to-one, we will be able to then expand that aperture and have a one-to-many relationship where the remote pilot will be monitoring a fleet of aircraft. And so we think of this as a staged approach where we'll go, one-to-one, 1 to 2, 1 to 10, 1 to 50, it gets larger. But in all these phases, our level of autonomy will be outpacing the kind of directly deployed ratio, if that makes sense. Like we'll be developing autonomy that can support fleet operations with a one-to-many, even while we're still operating one-to-one in the national airspace.
We have had just take a little bit of extra time here. We have had a question from outside just about, do you see any challenges with electric propulsion up to your 300 miles thing, or going beyond that as you look forward? Do you think electric propulsion's got the runway to get you to where you eventually may go all electric? I don't know. What do you see the challenges on the electric propulsion?
Yeah, so like I mentioned, we're starting with hybrid electric, so it's like a flying Prius, but that's because we need the range. And today's battery technology that's off the shelf and available right now doesn't support the 300-mile range for a system of this scale. We're designing the Chaparral to have all electric propulsors though. So the vertical lift fans, the forward propulsion, that's all electric motor based. So it's a system where the heart of the power generation can be easily swapped out for downstream applications. We've had a few customers already tell us, an all electric variant of Chaparral could meet some of the missions that they're looking to serve. But at this time, the majority of the missions, the majority of the customer need really does require that longer range. So that's why we're starting with hybrid electric. But I can see down the road, because of the way we've architected the system, we can very easily make an all electric variant or other even more interesting variations like hydrogen fuel cell that could actually be more of a drop-in replacement with the same range that we're developing now on hybrid electric. So there's definitely a path to zero emissions on Chaparral.
Sorry, thank you, Dave. So my family's come to rely on delivery for dog food, cat food, and boxes of wine over the last few months. So I'm going to go build a landing pad in my yard. So now we're going to go. Thank you.
Send me your coordinates, and I hope you have a big backyard.
Thank you, Dave. Now for our final showcase, starting with the video. Thank you. Thank you. And now we are joined by Virginia Tech MAP Director, Mark Blanks. Hi, Mark. How are you?
Doing great this morning. Thanks, Graham. Great to be here.
Thanks for joining us. So MAP has done some great work under the UAS integration pilot program, which I think has just ended, really. And now you're beginning work under the follow-on, the Beyond program, working with the FAA and industry. So can you give us some idea of what you achieved, what the milestones you achieved under IPP, and then how you will now go forward in Beyond, what you plan to do and extend that in Beyond?
Absolutely. So under the IPP program, we were very fortunate to have some really early wins. We had a series of partners who we've been partnering with for actually a number of years. And because of that, when we started IPP and there was a lot of emphasis on moving quickly, we were able to get some big things like that first air carrier certificate with Wing and to launch a real world drone delivery program that's still running right now. And, they're probably flying right at this moment over here in Christiansburg, delivering packages to residences. We also helped companies build a safety case for approval to nationally operate over people and beyond line of sight. That was with State Farm doing damage assessments, and we're working some of the really long distance detect and avoid work as well. And so Beyond is to take that and build and make it go beyond visual line of sight even further. So the goal here in this new program is to rapidly move to operations by rule, or meaning we're not doing things on a case-by-case basis, but we're operating under rules that are developed and being published. We just had some come out, less than a month ago that help enable that all to go really long distance beyond visual line of sight or remote operations as well.
So are we then, if we go to this by rule type of operation, are we starting to need to have, onboard detect and avoid systems? So is that technology getting to the point where are we getting the standards, getting technologies that's ready to enable these types of operation?
Well, there's one thing I've learned running a test site for a number of years is that nothing's a silver bullet here. The detect and avoid is a really hard problem. To operate by rule, I would say, means we have a system, a holistic system that is able to mitigate the risk successfully. And we have a regulatory structure in place that can enable that without having to do waivers or one-off exemptions. And will that be onboard detect and avoid? Will it be ground-based? I really don't think it matters, to be quite honest, for that particular idea of operating by rule. The question is, can we do that safely, and have we mitigated all the risk? And so we're looking at concepts that are very diverse, I'll put it that way. And the technology in a lot of ways still has ways to go. I mean, we've that's a lesson learned, is the technology does not always perform as advertised. At the same time, what we are seeing is that a combination of technology, strategic and operational strategies can mitigate risk to the point where it is as safe or safer than anything else flying in the air.
So you, MAP was one of the teams selected back in 2013 to be an FAA designated test site. Since then, how has your role and the way you work with industry, how has that sort of evolved? And what is the sort of the key services that the things you really do for industry now, in the drone industry now?
Yeah, great question, because something I love to talk about. So in 2013, when the test sites first started, there was this vision that everybody could come to the test sites and fly anything they wanted and do whatever they wanted at the test sites. And at the time, there was no Part 107. There was no ability to commercially operate UAS. And so that was kind of where it started. The tools that were given to the test sites made that a little bit challenging as well, but also the real demand from the industry ended up being different than was expected. And so what we've seen is there's 7 test sites, and all 7 of those sites take a different approach to how they help support the industry. For us, we focused very heavily not on having wide open desert spaces for people to go fly anything they want, large, big, small, hazardous or not. We focus instead on how could we help businesses achieve their goals. And to do that, we help them build what we call risk-based safety cases, and we developed a process for those safety cases. And so we take companies from this business concept of what they want to do or what they're dreaming of doing through the whole process of building a concept of operations, assessing risk, collecting data through testing to show that risk mitigations work, through to an FAA approval. And because of that, we've seen our test site has produced some of the most groundbreaking waivers and exemptions out there that are still one of a kinds because we've been able to pull together those pieces. But that really requires more than just a place to fly. It's a lot of expertise. It's a lot of different groups here at the university and additional partnerships and relationships.
What sort of infrastructure have you had to build out to do that? Do you have the ability to do this sort of testing and data gathering in different types of environments across the state? Or I think it goes beyond Virginia, doesn't it, as well? So
yes, it does. We well, first of all, I tell my colleagues or other test site directors that I can't imagine doing their job without having the backing of a large university that has a lot of the research capabilities. We've been able to pull in a lot of different expertise from different parts of the university. For instance, doing injury testing, we were able to lean our Center for Injury Biomechanics, and we built a lab dedicated to crashing drones, and then all to assess risk. We built a drone part for flying things that we couldn't get FAA approval for. But then we actually ended up investing in mobile assets. We chose a different path. Instead of building one place that was the Field of Dreams, we built a mobile Field of Dreams. So we've got,
build it, and they will come. But no, it's not here; it's over there.
Yeah, exactly. We'll build it. We'll go to them. So we have done that. We have radars and mobile operation centers and other things that we can deploy elsewhere, and we do. We fly all over the country, majority in Virginia, but we go from Florida to California to the upper Northwest. We've kind of been all over the place, and it's really about where can we bring the greatest value to the customer, and that isn't always in Blacksburg, Virginia, although I love Blacksburg, Virginia.
Now you say you're associate. You've got the backing of a very large university. What does that mean for we've got a lot of students listening in? What does that mean for the students? Can they get involved in this through this or not?
Yes, we try to involve students wherever possible. I mean, we do want to help the university mission of education and outreach as well. And so for students' perspective, we employ about 10 to 12 undergraduate students every year. And then we have right now about 2 graduate students. And those positions, student turnover is a little bit high because they graduate and they move on and they go get great big jobs. And it's fascinating to watch and see. But we've been able to keep them included, although not quite at the level as if we were perhaps teaching every single class to students. But at the same time, they have been very involved in our students. We've tried to hire them whenever possible, because they're usually pretty good.
And I want to just bring it round here to the beginning, how we started when we started with ANRA technologies and unmanned traffic management and that sort of thing. So you were also involved in the UPP program, is that correct? Which was the UTM pilot program, which was really an effort to, I think, and you may correct me here, to kind of take what NASA had done with the original development of the construct of UTM and start to put that to work. I mean, could you talk a little bit about the role of sort of taking that sort of research concept and making it a reality?
Yeah, so we've been involved with NASA for years doing UTM TCL research, and Honor has been a great partner of ours for years. And we graduated from that, I guess, to the FAA, as the FAA adopted or at least incorporated much of the NASA architecture into their testing of UTM. And we were the only test site that's participated in 2 years of phase 1 and phase 2 of that. And as Amit described, you know, the FAA has taken a very building block approach to how they would implement the services. And I think what we've done in the recent time is we've seen a holistic system that has the real capability to bring tremendous value, not just to unmanned aircraft operators, but also to public safety and to other manned aviation users. I do think we should be realistic, though, and note that it's probably a little ways away still. It's not going to happen tomorrow across the entire airspace. We'll continue that building block approach, I think. But overall, we're seeing, I think, the blocks getting bigger, and we should see implementation happening much sooner, much quicker.
And we have a little bit of time here, so I wanted to just ask you, since we were talking, you know, I think the opening thing talked about flying cars and what's that. So, I mean, do you expect that, you know, that Virginia Tech or MAP and/or will play a role in how we grow this up into the sort of urban air mobility, advanced air mobility, which is more than just urban, it's rural and regional? Do you see that there's a role that you guys could also play as we move forward into that market?
I certainly believe we'll be involved with the urban air mobility and the advanced air mobility market. I think it'll be different. I think the needs are different. If you look at this class of aircraft, you know, the certification process is much more closely aligned with the traditional manned certification process. What I see us doing there is probably two main issues. One is helping to test subcomponents, subsystems, and perhaps some flight tests. I'm not a big believer in just being a place to fly, though, so we have more value than that. Where the work's happening right now is the airspace integration concepts of how do you integrate this new type of technology into the airspace. And there's already a number of projects going on using surrogates, either a surrogate drone or a surrogate manned aircraft to represent the UAM vehicle or the advanced air mobility vehicle. Those integration topics are ones that are broader than any single company and typically government funded. That's where we can bring together a lot of different companies and test those things in a kind of a group atmosphere that's very productive and very conducive. But yes, I think we're certainly addressing or looking at the future in our strategy as it comes to AAM. So.
Thank you, Mark, and again, thank you to all our presenters. And I've got a couple of extra minutes here, so I'll just recap. So we started out with ANRA Technologies, which is really about the drone operating system, the managing the fleets, the planning the flights, the enabling of real, practical, and valuable drone operations, and they gave us a vision of the future about how that technology that's being developed for drones today could grow into the air mobility side of things. We then moved to space and Aerion's ability to track aircraft all around the world from satellites and really provide the regulators and the airspace managers incredible data that not only allows them to manage their fleets, but really start drilling into the details of the data and learn safety lessons, efficiency lessons, and maybe start to roll out new tools and services that could mean a lot for aviation going forward. We then moved over to Dave and Elroy Air, which is really talking about bringing a new capability to aviation. We do have regional air cargo today, but as Dave says, those airplanes are not. They don't have very high utilization. It's an essential capability, but there's a lot of waiting around. And if we can bring this capability of unmanned to this market, we can really bring express logistics to this regional connectivity, this middle mile as they call it. And so I think there's a lot of interest in that. And then we wrapped up with Mark, who really at Virginia Tech MAP, who really kind of painted the picture of of why it's important that that with government support, the academic community gets involved with the industry in solving the tough problems that need to be solved if we're going to enable these capabilities. And again, he emphasizes it's a crawl, walk, run. None of what we saw today can happen overnight. It has strategy. But this ability to work together in a collaborative environment, I think, is key to making these things practical and real. So with that, oh no, we do actually. Mark, can I just quickly go back to you, and I will ask this question if you're still there, Mark. Thanks. The question, this is, it's to do with recreational drone operations, and you may know the rules better than I do. There seems to be some confusion on some drone boards for drones that weigh under 250 grams. Is part 107 a must to fly in restricted areas always, or is a drone under 250 grams not needed? It says it's under the weight requires to register the drone. Not sure I quite understand the question there, but I think it's about whether or not you're free to operate even in restricted areas if you're under 250 grams, or whether you will always, if you're in a restricted area, you need to get FAA approval. Does that make sense to you?
Like I say, it depends on what we're calling a restricted area. So that, first of all, Part 107 applies even if you're under 250 grams, if you're doing it for commercial use,
right?
Hire. So if it doesn't matter how big it is, if it's for hire. But as far as restricted areas, I guess we would need clarification on what we
want. No, okay, yeah, it just says a must to fly in restricted areas always. So I don't, maybe they want to go and fly around their local military base. I don't know. And who could stop them?
I don't think that would end. I don't think that would end well, to be quite honest.
It probably would not end well. So, folks, I think you're encouraged now to move to the Hoover app and continue to do the what do they call it? Networking, that's the word. So again, I want to thank all of our participants today. You were great. Thank you to Fairfax County Economic Development Authority for putting this on, for inviting me to moderate. I'm Graham Warwick, Aviation Week, and all I can say is read Aviation Week. We're pretty good. Thank you very much.
Wow. Well, first of all, that was a fantastic lineup of innovative aviation technology, Graham, and thank you so much for your very effective moderation. And actually, before we head on to the networking session, we do have a closing presentation where you will learn more about Virginia's assets and leadership position in unmanned air systems. Please welcome Tracy Tynan, Director of Virginia Unmanned Systems Center at CIT, the Center for Innovative Technology. Tracy is well known in economic development circles, having worked in various business investment roles at Virginia Economic Development Partnership and the Greater Richmond Partnership. Some fun facts about Tracy. She is a student of the University of Virginia, and during her time there, she was also a top competitive diver and record holder on the swim and dive team at her alma mater. Without further ado, here's Tracy Tynan.
Well, thank you, Juhi. I think I'm going to need to definitely shorten that bio if you're reaching back to my sporting days quite a while ago at this point. As Juhi mentioned, I'm the director for the Virginia Unmanned Systems Center, which is at CIT. So if we could go ahead and move to the first slide. I'd like to mention, or it's worth noting, that CIT is part of the Center for Innovative Technology, and that CIT is a nonprofit entity that's funded by the Virginia General Assembly. So that also means we've got good connectivity and access to the administration. So this first slide is important because it illustrates the administration's commitment to growing and supporting the unmanned systems industry within the Commonwealth. This quote is actually from Governor Northam when he attended AUVSI's Exponential event in Chicago, which is the largest unmanned systems conference in the world. And of course, this was just prior to COVID. But not only did the governor attend and participate in our Virginia pavilion, but we were also fortunate to have Secretary of Commerce and Trade, Brian Ball, as well as Secretary Brian Moran of Public Safety and Homeland Security joining us as well. Additionally, we had about 18 Virginia companies that were sponsors of the Virginia Pavilion, and we will recognize them a little bit later in this presentation. Could I have the next slide, please? So before I talk more specifically about the Virginia Unmanned Systems Center, I'd like to update you a little bit on recent changes that have occurred at CIT. And this, of course, is an overview of our structure. You see up there VIPA, or the Virginia Innovation Partnership Authority. And VIPA was created out of the last year's General Assembly, and its intention is to cull together the different innovation and entrepreneurial initiatives and entities that exist across the Commonwealth and put them under one umbrella. VIPA is the umbrella, and then CIT is now the administrative arm over this new entrepreneurial ecosystem. So our new structure at CIT now includes the Entrepreneurial Ecosystem Division, along with our long-standing commercialization and investment divisions, which I will speak to a little bit more in a moment. Under strategic initiatives, you'll find the Unmanned Systems Center, smart communities, cybersecurity initiatives, and other agendas. Next slide, please. So since everyone tends to be interested in sources of dollars or funding, I want to go ahead and point out a few of the funds that CIT has to offer to support startups and early stage technology-based companies. We essentially have grants such as the Commonwealth Commercialization Fund, or CCF, and the Virginia Founders Fund, but we also have gap funds, which take an equity stake in promising young companies. We encourage and ask you to encourage young companies to look into these funding opportunities. Probably the best way to find out more about that is just to go to our website at cit.org. Next slide, please. This just focuses a little bit more on our strategic initiatives, which I already mentioned, and where we have recently received a lot of attention is in our Smart Communities initiative, where Stafford, Virginia is almost like our test bed, where we're teaming with the Federal Department of Homeland Security on some new technologies that are being tested there. And then obviously Unmanned Systems is part of that division, as well as cybersecurity. All right, next slide, please. And we can go ahead here and focus now a little bit on the Virginia Unmanned Systems Center itself. You'll see in the middle of this slide that our mission is to drive growth, acceptance, and adoption of unmanned systems in air, land, sea, and space, or all the domains, and across all regions of the Commonwealth. So we also serve as a Commonwealth's connection point for industry, academia, and government that are engaged with unmanned systems activities in Virginia. So through collaboration, communication, and the convening of meetings and events, the Unmanned Systems Center helps to foster that growth and acceptance that we just mentioned. You'll note that, or maybe you already know, that Virginia was ranked #1 for unmanned aerial systems by Business Facility magazines for the last 2 years in a row. And Business Facilities magazine is a well-respected economic development publication. Many of the companies and the individuals and the initiatives that have really brought a light to shine on Virginia can share in the credit for this accolade, and we appreciate all that they do to put Virginia on that map. Next slide, please. So I want to take a look at our initiatives and some of our outreach, but I want to start by taking a closer look at a couple of important initiatives. Many of you are already aware of the package delivery by drone that's being done by Wing down with Mark Blanks in Christiansburg, Virginia. But we also have another Virginia company that is making headlines in the drone delivery world, and that is called Drone Up. And Drone Up is one of our premier companies in Virginia, and they're based in Virginia Beach. Last fall, along with UPS's Flight Forward division, Drone Up successfully executed multi-drone delivery of COVID test kits. And this demonstrated sort of how private sector drone operators can effectively supplement emergency response. Their final report actually led to Drone Up working with Walmart to deliver test kits around the country. And I don't know if you saw recently, but Walmart has now asked Drone Up to start delivering the new coffee Coca-Cola in Coffee County, Georgia. So I think that was quite the attention getting event there. Next slide, please. So an example of collaboration between industry and state agencies is the Virginia Flight Information Exchange, or what we fondly call the Virginia FIX, F-I-X. It was a local Fairfax company, ATA, that approached CIT Unmanned Systems Center with a concept for sharing drone data, which would help ensure the safety and openness of Virginia skies. So we reached out to the Virginia Department of Aviation, to the Department of Transportation, as well as the Departments of Public Safety and Homeland Security and the Department of Emergency Management. All were in agreement to pursue this pilot program. This program is now entering phase 2 following a successful pilot period, and Virginia FIX will provide key members of state and local government an important authoritative voice in communicating advisory information to ensure safe, transparent operations. There's a business need for the Virginia FIX. Virginia state and local government have been aggressive early adopters of UAS, and as a result, they've already seen some of the challenges of UAS operations. Virginia FIX was created in direct response to those needs identified at the state and local government level through dialogue and working groups. Virginia FIX is part of Virginia's approach to address key policy and safety concerns at the state and local level, while also maintaining that open and free airspace in the nation. So really, though, to be clear, I need to state what the Virginia FIX is not. It is not a UAS traffic management solution. It is not a new regulation. It's not a flight planning or fleet management solution. Rather, it's an experiment in the value, the opportunity, and the challenges of information sharing by and between state and local agencies, industry, and the public. But most notably, it's an open and public asset owned by the Commonwealth of Virginia with no licensing or intellectual property restrictions and open interfaces. Virginia is now actively working to build collaborative relationships with multiple states across the country to ensure that we are sharing lessons learned and helping where we can. Right below the Virginia FIX logo there, you see drone responders. And I bring this up because I want to mention the very important role that public safety plays in the use of unmanned aerial systems. So Virginia is very fortunate to have some of the best first responders trained to use drone technology. Fairfax County is an excellent example of that. And Fairfax did an incredible job of a concentrated public outreach program to inform their citizens about the use of drones by public safety officials. Their series of town hall meetings led to widespread acceptance of these technologies and really became a model for other localities. This was actually similar to the extensive public education that Wing undertook down in Christiansburg, Virginia, when introducing drone deliveries in Christiansburg. But both are great examples of Virginia's leadership in gaining public acceptance for our unmanned aerial systems. Drone Responders itself is the fastest growing nonprofit program supporting public safety UAS and, quote, drones for good. Their directors are very own Charles Werner of Charlottesville, Virginia, where he served as the Charlottesville Fire Department chief, served in the fire department for 37 years, the last 10 of which he served as chief. He's also served for 2 years as a senior advisor and acting deputy state director, coordinator for the Virginia Department of Emergency Management. And he's now on our Virginia Unmanned Systems Advisory Board. And Charles is always an integral part to the development of and use of UAS in public safety. So next slide, please. So really the only thing I'll point out on this slide is that we're providing an updated strategic plan for Virginia's unmanned systems industry, and that should be available in the very near future, at least by the end of the first quarter. On the next slide, please. Communications is, of course, key to success and is always a big challenge for a new industry. So one of the first things we did a little over 2 years ago was to try to figure out who is here in the Commonwealth that is engaging in unmanned systems technologies. It's not like there's some NAICS code that we can all just refer to and pull up a list of who is here. So we actually did some outreach and completed our initial benchmark study and identified just under 200 companies. But at this point, I'd really like to ask our audience that if you're not part of our Virginia Unmanned Systems directory for unmanned systems companies, that you please reach out to us so we can add you to our list. We completed that benchmark study, but I know that we've got at least another 20 companies that we've added to it over the last 2 years. But anyway, we certainly appreciate you reaching out to add your company as well. You're looking at the Telly Awards logo there, which the Telly Awards is essentially the Oscars for videos that are not created for the big screen. And that went to our Unmanned Systems 101 video that we created and that we share in as many venues as possible, as it's a key educational tool for the uninitiated in unmanned systems. It actually won 3 separate awards, one of which was a silver and the coveted People's Choice Award. Should you have any venues where you would like to have more information about the unmanned systems industry, please contact us. We're happy to provide that kind of information to you and bring a little more attention to unmanned systems in air, land, sea, and space. So speaking of videos, however, we did just send out our most recent production, which featured industry testimonial support of the unmanned systems industry. And we sent it directly to the General Assembly members. And on the video, we include Senator Warner, Governor Northam. We have Nate from Dominion Energy. We've got Charles from Drone Responders, Drone Up, Huntington Ingalls, and Verizon Skyward on the video as well. Just letting the legislators know that this is an important and growing industry in Virginia, and we need their assistance and their attention to make it successful. All right, on the next slide, please. This is just a quick moment to introduce our stellar advisory board. We have individuals representing all domains and from different regions of the Commonwealth. So if you take a look at some of the names here, if there's anyone that you feel could be helpful to you, please reach out to us, as I'm happy to make those introductions. Some of our newest members include Lisa Ellman, who is the Executive Director for the Commercial Drone Alliance in Washington, D.C., who work to promote good policy for drones at the federal level. We also have the retired Rear Admiral Nevin Carr, who's now at Leidos, but Admiral Carr is helping us with our maritime efforts. You see Nicholas Devereaux there, who is on board with Wing now, but formerly of Senator Warner's office for the last 10 years. David Bowles, former Center Director for NASA Langley, and now head of the Virginia Institute for Spaceflight and Autonomy is on our board. So we have a whole host of expertise here, and I would like you to feel free to contact us if you would want to talk to any of these folks as well. Next slide, please. So lastly, this is just a very colorful slide of a few of the logos of the companies that have supported the unmanned systems industry in Virginia. These happen to be the Virginia Pavilion sponsors that were at AUVSI Exponential. But it's simply amazing how these new technologies are literally found in so many facets of industry. And so with that, I'll close and say I'd like to thank you for your time and attention, and I'll be happy to take any question on the HUVA platform in the chat rooms. But here's our contact information, and we'd love to hear from any of you. Thanks so much for your attention.
Thank you, Tracy. That was extremely informative. And all I can say is that it's a great time to be in aviation in Virginia. Well, folks, that brings us to the end of our formal programming for today and to the beginning of our networking sessions. Real quick, for the next 30 minutes or so, you can visit different networking rooms that have been created within the HUVA website under the community section, whether you're using the app or your desktop browser. Go to the community section, click on meetups, find the company, one of the companies that has presented today, and join their meeting room. You will be able to enable your microphones as well as videos at your discretion. Please feel free to ask them any questions that were not addressed, but this is an opportunity for you to interact live with one another, as well as many of our speakers who are standing by to engage with you. There will be an announcement 5 minutes before the rooms are closed at around 11 a.m. And in that time period, up until that time period, you're free to move in and out of different networking rooms based on your preference. We will return with live programming next week, February 3rd, when we journey into space. In the meantime, happy networking and thank you again for joining.